I can't hear you, Beth.
I think you're still muted.
Yeah, I was still muted. I do that a lot. So the place that I ended up yesterday was getting the total losses. And after class, I went and got the draws. And then I put that all together in a data table and I calculated for total number of games. The reason why I did that was for histogram stuff, which I was trying to do last night, and it ended up in a pile that I lit on fire. So that's where we're starting this conversation, is with this type. This is the information we have so far. Then the next thing that we did was we looked at the total number of games played included in our data table, and we realized that is way too many for us to use this wonderful API for free. So we looked at the total number of dates that were present in the original data frame that we created. And that is a much more manageable number. So we put all of those dates into a list. And then after that, because we noticed in the documentation that the time was in a Unix format, we decided to convert the original time that we have into a Unix format. And we still have that same length. Then after that is when we put in our API request. And this is me putting in my API key. This is the latitude and longitude for Berlin, Germany. And then we get to the next part. So this is the list where I want all of my stuff to end up. And what we did is we created a for loop where we had the base URL, the API key, the latitude and the longitude. And then this is the part that we're iterating with, or this is the variable that we're working with, is this individual date. So we ended up with a list, or rather with a single entry called response. Then we transformed that entry into a JSON format. Then we told that JSON entry that we wanted only this information here. So we only got the weather for that day. And we went with a weather icon because we read the problem and it said number, like win percentage for games where it was raining. And we decided that if they wanted all precipitation, they would have said precipitation instead of the word rain. So we just wanted the icon part where it says rain. And so that was the easiest way to get that information. There were some other stuff, like the summary, but that was a little bit more complicated, so we decided to go with the icon. And I think that list of stuff is somewhere, down here somewhere. I don't even know, but it's in the documentation somewhere. And then this part here, we wanted to exclude a whole bunch of information that we didn't need. Then once we have that single entry, we appended it to the list that we created originally. So what we ended up with was an output that has a length of 165, which is the same as our number of days. And then I transformed both of those lists into a data frame and put them together. So now I have a data frame that has the dates of all the games that were played by day with the weather. And I put that, I did a merge with my original data frame and my weather data frame. So now I have weather on my original data frame. And my plan is to move all of my API stuff up to the very beginning and running through all the SQL stuff after it, so that my fancy finished data frame that I started with now has an extra column called weather right with it for me to move forward.
Awesome. That's an excellent and thorough explanation.
Yeah, Jacob, let me practice. So do you all have any questions? I think that's probably where the most stuff is going on.
Okay. Yeah, I think that is pretty clear and concise. But speaking of Jacob, let us see how Jacob got there.
I've probably got to come back to me. My browser's froze or something.
All right, on to Brendan then.
Sure. Let me go ahead and share. All right. So we basically did the same process that Beth did, only we went about it a little bit differently in how we kind of structured the data to get there. So, here we did the same thing. You get home team, away team, date, FTHG, FTHG, FTR. You get your 992 games from the 2011 season. And so you see here's where we actually go and call the weather API. So you start with the base URL here, and then your longitude and latitude for Berlin. And what I actually did is, instead of going directly into a list, what I ended up doing was doing a dictionary. And so then I looked for the dates in that date column .unique. And all I did was just print date query. These are just debug statements to make sure that we're iterating through properly, making sure everything's going smoothly if we run into any problems later on. And then here's where I generate the request URL. So you can see we basically did the same thing where we put date, we put just a generic time, we chose 12, and then we did the same excluding that Beth did as well, where we're taking out all the information that we don't need, just going with the daily. And then you can see here, we call the API, get the information back, transform it into a JSON, make sure that we get it back properly. You can see we print the response for the icon, which is the same field that we used to get whether it rained or not as well, and then the precipitation probability, just because we wanted to make sure that those two were lining up. And then what I did was I would do weather, and I would set the date as a key to the dictionary, and then for that key, I would set the value for icon. And so what that gave me is it gave me a dictionary of all 165 days. We did the same thing that you did, Beth, where we just figured out how many unique days that you actually had. And it gave me a dictionary of a key for that date and then what the icon weather was. And so from there, what I did was I created a list where I said for date in main data, df.date. So going through, iterating through this whole column here and looking at all the different dates. Weather list.append, and then I would just append whatever was the icon value for that particular date in the weather dictionary. And then I just did weather data df, or main data df, weather is equal to weather list, which gave me this. And then kind of going where Beth was going as well, we did think that we were going to worry about getting all the data and then doing actually all the processing, like calculating how many goals, how many wins. But we wanted to get all that data together in a single place first. And just to try to make it a little bit easier when you're doing the calculation for rain winds, all we did was we created a new column, did rain, filled it with zeros, and then where the weather is equal to rain, just set it equal to 1. So then you can see here what that ends up doing is it gives you a column, kind of like basically just a binary 1, 0, did it rain for all the rain games. And that's basically how we went about going for it.
Awesome. And then from there, when you guys go home and continue on with this problem, you can have some ifs and wheres going on to separate the winnings when it rained and the winnings when it didn't rain.
Mm-hmm.
Jacob, how's your browser doing?
It's back up. It's back up.
All right,
Real quick. Let us get out of here. I just signed up for an extra account since those 992 dates just listed in there, and I just pretty much did the for loop through all those dates, put them all in that list of raining, and just put forecasts on the column. That's it.
All right. So we have seen 3 similar but slightly different ways of going about this problem. And thank you, brave souls, for sharing tonight and for your hard work. Folks watching at home, if you watched yesterday's lecture and today's, you should be through the SQL. You should be through the API. And now all you have to do is follow the steps to combine them, figure out your gains when raining and what those outcomes were, make your histogram, put it into MongoDB. We're almost home, folks. All right, well, thank